All right, welcome to the Explainer. Today we're going to talk about something that makes a lot of people a little nervous, algebra. But here's an idea. What if we stop thinking about it as a math class and start thinking about it as a secret code? I mean, when you hear that word, algebra, your mind probably jumps straight to classrooms and homework, right? But is that really all it is? Just another hurdle to get through in school? Or is it something way more interesting? A powerful code that lets us solve real-world mysteries. That's how we're going to approach it today. Algebra is a language, and once you learn to speak it, you can solve all kinds of puzzles.
Now, with any new language, the first thing you've got to do is learn the vocabulary. For algebra, that just means translating simple English phrases into math. And trust me, it's probably more straightforward than you think.
Take a look. X divided by b becomes, well, x over b. Simple enough. Now, 4 less than r, this is where you have to pay attention. It's r minus 4, not the other way around. The order is key. And q decreased by d is just q minus d. Just like that, you're starting to speak the language.
So let's build a slightly longer sentence. We do it piece by piece. 2g, that's 2g. And 3 more than that. Well, we just tack on a plus 3. So the final code is 2g plus 3. See, we're not just translating single words anymore, we're actually forming ideas.
Okay, let's try a quick problem. Say a game's total score was 30 points. If we know Gary scored X points, how would we write out what his teammate Nancy scored? Take a second to think about it.
You just take the total, 30, and subtract the part you already know, which is X. This is a really powerful idea in algebra. You can use one unknown to help define another. It's a total game changer. So, we know how to write the code. What's next? Well, we have to run it. This is the part where we plug in real numbers to our expressions and see what answers pop out.
For our next few challenges, we're going to use this key. Think of it as our official decoder ring. Every time you see an A, it's a 10. Every time you see a B, it's an 8. You get the idea.
All right, let's put that decoder ring to work. Our expression is AC minus D. Step 1, we swap in the numbers from our key. So that gives us 10 times 5 minus 24. Step 2, we follow the order of operations and multiply first, which gives us 50. And finally, we solve it. 50 minus 24 is 26. See, it's a nice, clean, logical process.
Okay, this is so important. In this language, grammar is everything. Look at the difference some parentheses make. On the left, we square the a first, so 10 squared is 100. Then we multiply and subtract, getting 180. But on the right, those parentheses force us to multiply 2 by a first, giving us 20. We square that to get 400. The final answer, 380. A tiny little change in the code creates a huge difference in the result.
Now, this whole code thing isn't just for number puzzles. This is the language we use to make sense of the world around us. It's behind everything from building bridges to writing computer programs.
Think about something as simple as an equilateral triangle. You know, where all 3 sides are the same length. If we say the perimeter, the total distance around, is p, we can describe the length of just one side with a super simple formula, p divided by 3. It's elegant and it's efficient.
So let's actually apply that. We've got a rectangle, but its size is defined by x. If we're told that x equals 12, we can figure out everything. We just plug 12 into the expressions. The length becomes 24 meters, the width becomes 7 meters. A quick multiplication gives us the area, 168 square meters. We just used algebra to find a real physical size. Pretty cool.
Okay, it is time for the final boss. We've learned how to translate words, plug in numbers, and solve. Now we're going to put it all together to crack one last big mystery. So here it is. At first glance, it just looks like a messy jumble of words, right? A confusing story problem. But believe it or not, hidden inside all that text is a clean, solvable algebra equation, just waiting for us to find it. Let's decode this thing. First, we define all our coins in terms of one variable, p for pennies. That lets us write one single equation for the total value of the coins in cents, 181p. We also know that the total value has to be between 500 and 600 cents. So now it's just a little puzzle. What whole number, when you multiply it by 181, lands in that narrow window? There's only one possible answer. It has to be 3.
And once we know that p equals 3, the rest is like dominoes. Everything just falls right into place. That means we have 3 pennies, which means we have 9 dimes, which means we have 18 quarters. And just like that, the mystery is solved.
Well, let's just double check. What's the total value? Well, 3 cents from the pennies, 90 cents from the dimes, and $4.50 from the quarters. Add it all up, and you get $5.43. And what do you know? That is perfectly between our $5 and $6 range. A perfect solution, all because we could speak the language of algebra.
So you see, algebra is so much more than just a school subject. It's a tool, it's a system for thinking logically, and it's a powerful language for making sense of the world. So now that you know the basics of how to speak it, the only question left is, what problems will you solve?